An exponent is when we have an expression of a to the b. A is going to be the base. We identify b as the exponent. Now if it has a term in front of it, a constant value, we would also identify that as the coefficient. So that would be something like 2x to the third. The 2 would represent the coefficient. But right now we're just looking at what the exponent is. So if I wrote something as 2 to the fourth, we understand that as being 2 times 2 times 2 times 2, having 4 of them. It's a shorthand version of writing a lot larger value by looking at its factors. Now 2 times 2 times 2 times 2 comes out to be 16. And that's really the way we could expand it, but we're going to work more with just kind of like the properties that come with exponents. Other things we need to be aware of is a to the first, or any exponent of 1 is going to give the original value, and any exponent of 0 is going to make the result 1. And that becomes from when we factor down, it's really difficult to get 0 in multiplication. We really get to 1 because that is our multiplicative identity, so any term to the 0 power will be an answer of 1. For the product rule, we're going to look at a to the b times a to c. And these must have the same base, which in this case is the a's. We're going to take something like 4 to the 6th and 4 to the 3rd. Together, that says, well, I have 6 4s, and I have 3 4s, and together, that gives me 9 4s. Now I could sit there with a calculator and multiply 4 to the 6th, or 4 times itself 6 times. I could do the same thing with 4 to the 3rd and get some really large value. What we want is just a simple form of saying 4 to the 9th. Now we can also see here that 6 plus 3 gave us 9, which is also the product rule of saying it's b plus c. In the power rule, we're going to look at something as a to b to c. So it's an exponent to an exponent. So let's say I went back to 4 to the 6th to the 3rd. That would be the same as expanding out to say 4 to the 6th to the 6th to the 6th, which up here we would have just added the exponents together, which gives us 4 to the 18th. Now how do I get 18 other than adding the 3 6's? Well, it's by multiplying 6 times 3, which comes out to our power rule being we multiply the exponents. Now we have to be careful not to mix those up, the product rule and the power rule, but these are the two rules we're going to use for simplifying expressions. When we look at 8x to the 4th y squared minus 3x to the 4th y to the 9th, we don't have any exponents on the outside where we have to worry about the power rule. So let's just kind of resort things and look at what we have in common. So we have 8 and negative 3. We have x to the 4th and x to the 4th. We have y squared and y to the 9th. So what we're doing here is really reordering with like terms. So there's no power rule, so we're really going to go to product rule just to make sure each thing goes together, because we kind of have a coefficient set, an x set, and a y set. So now when I use the product rule, 8 and negative 3 becomes negative 24. X to the 4th and x to the 4th becomes x to the 8th. And y squared and y to the 9th becomes y to the 11th. For our next one, we're going to come down and look at having to deal with the power rule first. So power rule before product rule. And where that comes from is if when you first learned order of operations, we had the power rule is actually a form of exponents. So if I had this term of 4 to the 6th to the 3rd, 4 to the 6th is just a number. So when I take that number and cube it, I'm really doing an exponent operation. So that's where we come from exponents. Whereas product rule, a number times a number, is really multiplication. So power rule comes from exponents. Product rule comes from multiplication. So from that, we usually should look for power rule before product rule. And we also could see that I'm not going to do a and a squared and call it a to the 3rd when I have exponents on the outside. So then we look at power rule first. So I'm going to take the second expression first. I got 3 squared. A squared squared becomes a to the 4th, and b squared. So that term gets used, it's applied to each exponent. Now sometimes we want to call that distribute. And it is distributed to each one, but it's not distributive properties. And you have to be careful with that. So it gets applied to each term. So now I have 9 a to the 4th b squared. I go back to the first one. I have negative 2 squared or negative 2 squared. These are what we have to be careful with. Negative 2 squared is like saying negative 2 times negative 2, which comes out to be a positive 4. That is not the same as saying negative and then 2 squared, because that just becomes squaring it and keeping the negative. What we have here is the parentheses, so that's going to become a 4 a squared b to the 4th, and that's again kind of distributing it to each term. Now in the last set, I'm going to put my coefficients together. It gives me 36. A squared and a to the 4th is a to the 6th, and b to the 4th and b squared is b to the 6th. So now for some more practice problems. Here I have x to the 3rd and y to the 5th, x to the 8th and y to the 10th. This one is just going to be a product rule. I have 11 x's and I have 15 y's, so it's x to the 11th, y to the 15th. In our one to the right here, I have 5, negative 3, negative 2, a squared, b to the 3rd. And that's resorting them. So my coefficients, which I'll take care of first, negative 3 and negative 2 is 6 times 5 is 30. A and a squared becomes a to the 3rd. B and b to the 3rd becomes b to the 4th. So it's 30, a to the 3rd, b to the 4th. For the next one, we have negative 18 inside the squared, so we need to multiply that by itself. That comes out to be 324, and that's a positive 324 because it's a negative times a negative. Then we have m to the 4th, n squared, negative 1/6, mn squared, and that's because none of those had an exponent on them. So I'm going to take 324, divide it by negative 1/6. That comes out to be negative 54. I'm sorry, I should say I'm going to divide by negative 6 or multiply it by negative 1/6. So that takes care of my coefficients. I have m to the 4th and m. Now, I'm not going to worry about this negative as it pertains to m and n, because really it has nothing to do with it. The negative is just the value out in front. If it was a positive 1/6, it just doesn't affect it at all. So m to the 4th and m becomes m to the 5th. N squared and n squared becomes n to the 4th. Our next one here, we're finding the area of a triangle. So this is going to be 1/2 the base, 5 m to the 3rd, n to the 4th, times the height of 4 m n to the 5th. So if I resort this, 1/2, 5, 4, m to the 3rd, m, n to the 4th, n to the 5th. So put each piece together, coefficients, m's, then n's. 5 times 4 divided by 2, or times 1/2, comes out to be 10. I then have m to the 4th and n to the 9th by adding those two together. Next, I suddenly have addition. So here, I want to get these terms to combine, but in order for these two sets to combine, they have to have the same exponents, or like terms. And that comes from when we've talked about before, like 2x plus 3x, we would say equals 5x, or 2xy plus 3xy equals 5xy. But if they're not the same, so 3x plus 2y, that one's kind of stuck. So we look here, I have negative 8 x to the 3rd y, then I have 36 x to the 3rd y. They both have an x to the 3rd y in them, so that can be combined. And then I look at the coefficients. Now it's not 36 times negative 8, it's a plus. So that's just going to be 28 x to the 3rd y. Now we come to the last one, and that's going to be the same idea, because it's not a negative in parentheses like previous ones we've had. It's saying we have 1 r to the 6th, s to the 10th, and we're going to subtract it from whatever we have here. So the first thing we do is the power rule. And again, I have a negative 3 squared, so that's a positive 9. R to the 6th, s to the 10th. minus r to the 6th s to the 10th. So 9 of these minus 1 of these gives me 8 r to the 6th s to the 10th.